The discovery of a wormhole which works as we theorize would herald a new dawn for human civilization. It would enable faster-than-light travel, time machines, travel to parallel universes, and even invisibility cloaks. But based on our current knowledge, there are no decent-sized wormholes within our sphere of influence at this point in time. So, why don't we just build one? Starting at number 4. We already did. A wormhole is a shortcut consisting of two openings at different points in space-time with an invisible tunnel between the two, allowing things to travel between them. At present, wormholes are only a theoretical structure, since we've never actually seen any kind of forced jump between 2 points. Except that's not true, because we totally did see that when scientists at the Autonomous University of Barcelona straight up built a wormhole like a bunch of total wormhole bosses. However, this wormhole wasn't anything like the ones in Portal. You couldn't send physical matter through it. But you could send magnetic waves from one point to another with the space in between rendered entirely devoid of magnetic forces. The study surrounding the Wormhole project was co-authored by doctoral physics candidate Jordi Prat-Camps, and he described the magnetic field as being transferred through an extra special dimension. It's nice to be extra special. This technology probably can't be modified to assist in the field of space travel, with its most practical application being to help make new MRI scanning machines that feel less like being forced into a pizza oven. But Senor Prat-Camps' work does provide us with proof of concept for the idea of a wormhole. It shows that magnetic forces at least are capable of traveling undetected across space-time. So if we wanted to build on this knowledge and construct an actual working wormhole, where would we start? At 3. Build a white hole. White holes are the theoretical opposites of black holes. They force out light and matter and prevent it from entering, whereas black holes devour light and matter and prevent it from escaping. Basically, white holes are like that really hot girl at the mall who rejects your every advance, and black holes are the clingy grandma who's been desperate for attention since Ronald Reagan died. It was 14 years ago, Grammy. Get over it. And just like poor grandma, white holes are potentially billions of years old. They may even be old versions of a black hole, or they might be a completely separate entity, but either way, it is believed that white and black holes are pretty special. Because with white holes forcing stuff out, that matter has to come from somewhere. And with black holes pulling stuff in, that matter also has to go somewhere. Therefore, we think that white and black holes might be the entrance and exit of a naturally occurring wormhole. Unfortunately, we have no idea how to build a white hole, and nor do we know for certain that they exist. The object GRB 060624 has been proposed as our potential first sighting of a white hole, but this is yet to be confirmed. However, we do know how to make a black hole because we've already made several baby ones in labs across the world. If we were to make a decent-sized one and park it outside of Earth, we could potentially send nanobots through and see where they end up, and according to most of our theories regarding the construction of wormholes, nanobots are about the limit when it comes to what we can squeeze through. At 2. Ring-a-ring-a wormholes. Mohammad Mansour is an Iranian physicist whose theories on faster-than-light travel and wormholes led him to being dubbed the next Einstein. In 2006, he published a controversial paper which claimed to explain how he could create macroscopic but easily transversible wormholes. His theoretical wormhole would exist on the Planck scale at first, which is the smallest level that physics currently recognizes. However, after building one tiny wormhole, he believes we could build a ring of several of them, with the space in between collapsing and forming a larger opening. This wormhole would be large enough to see with the naked eye, but nowhere near big enough to stick your tongue through, if you're so inclined. The creation of these tiny wormholes requires the existence of two things: particles of negative mass and the discovery of negative energy. Researchers in the US claim to have created a fluid with negative mass back in April 2017, so we're halfway there at least. But the discovery of negative energy is a different kettle of fish. Contrary to what your hippie aunt may say, negative energy cannot be created by thinking bad thoughts and touching yourself at night. Negative energy is a theoretical form of energy used to explain the certain effects observed in various fields. We think this kind of energy could be created by black holes by squeezing light, or through something called the Casimir effect. But so far, we haven't been able to pin down this elusive material from any of these sources. And so, nor can we make Muhammad's tiny wormhole ring a reality. And at number 1, the wormhole machine. If the negative mass fluid created back in April 2017 proves to act as we think it should, then we might be able to build a wormhole after all. Or, at the very least, rip open one side of a wormhole whose point of exit is unknown and which might expand beyond our control. But hey, you gotta break some eggs if you want to make an omelet. And by break some eggs, I mean potentially destroy the solar system. Which sounds like too many eggs to me. I don't even like omelet. Michio Kaku is a theoretical physicist who thinks we could create a giant version of the Hadron Collider on the outskirts of our solar system. Doing this would enable us to fire atoms around a circuit, with the eventual goal of smashing them together in an explosion so powerful it would split reality open. The split could be like a rip in a water balloon, with no known force capable of stopping it until it has torn our solar system apart. But Mr. Michio says we could potentially stabilize it with negative matter, allowing molecules and particles to travel through safely. To make a bigger wormhole, the size of a grapefruit, a fat orange, or a particularly swollen testicle, we'd need to harness 100 million years worth of the sun's energy. So until we become a Kardashev 3-type civilization capable of using stars like AA batteries, this simply isn't going to happen. Our best bet is to discover naturally occurring wormholes and play with them until they do as we say. Tiny wormholes might exist in something called quantum foam, with these fellas also requiring lots of negative matter to blow them up to a useful size. And also, remember the magnetic wormhole from the first entry.